Given enough time and enough depth, what's going to happen to the sediments? What's going to happen here, Julissa? That's good. How are you going to spot, how are you going to identify sedimentary rock when you see it? What's that? The question is, how are you going to spot it? How are you going to identify it when you see it? What's that, Stephen? Now, how do you know that's sedimentary rock? How do you know? How do you know? How do you know, Natasha? Look at it. How do you know it's stuck together? Oh. All right, now, why do you suppose you can see the layers here? Because if this river wasn't here, you wouldn't see the layers. What did the river do to the rock? At least the sedimentary rock. What's happening here, Courtney? Okay, but what did the river do to the sedimentary rock? You know, that could have been buried a million years ago, 10 million years ago, 50 million years ago. What do you think's going to happen to that animal? Now, there's a word for that. There's a word for that. What's that, Cherise? Suppose we dig down further into the sedimentary rock, into a layer that's underneath it. Maybe this fossil of a fish is found in here, and maybe something like this is found below it. Well, it's called a brachiopod, and to us it looks like a clam. And it's a shelled animal. If you had this fossil and you found it over here, which would you say is older? Which would you say is older? What would you say, Keisha? Why is the bottom older? All right, any idea where I am? Any idea? Well, I don't mean exact, I could tell you the exact location, but the type of landscape I'm on. Sharice, got a clue here? Deshante, I'm sorry. All right, Randy. Does that help? The island of Hawaii. There's something about the Hawaiian Islands. What is that? Well, what's that, Jonathan? Standing on the top of a volcano. Why am I not standing on sedimentary rock? Why do I have to be standing on another kind of rock that we're going to call non-sedimentary, at least for the time being? Why? Portia. What do you say, Chad? Sedimentary rock. What kind of rock am I standing on? What is that? What do you say there, Keisha? How is it different than sedimentary rock? Think the way this rock forms. How does it form? How does it form, Thomas? How does it form, Stephen? What comes out of a volcano? Okay. Now, what has to happen to magma, or in other words, molten rock, that's where the heat comes in. in order for it to become solid. Think about it. That's right. And what kind of rock is this non-sedimentary rock? It doesn't come from sediments. That's what Stephen said. Absolutely. Good. You know, the word, that's a good word. Another word for layers, strata. Okay. That's right. So here's a wonderful example. That's right. Now there's a word for that. That's good. Very good. This one's older. Right. No, it's not ice, Stephen. It's a kind of mountain. I'm standing on rock. No, that's not how this hole got here. Let me tell you where it was. All right, this is in an island. Hawaii. Hawaiian Islands. There's many islands. The biggest one is Hawaii, the one that has the capital, Oahu. That's right. So I'm standing on near the top of a volcano. Well, you're getting close. You're getting close. No. Wait a minute. We just got through saying, not 10 minutes ago, that if sediments get deposited in some sea and they get buried deep enough, they may be pressed into sedimentary rock. Now, I'm not standing on sediments, and I'm not standing on... Heat is necessary. Charisse. It comes to the surface. Some lava never comes to the surface. We can't call it lava, we have to call it magma. Once you say magma, you include the magma that comes to the surface that we call lava, or magma that never makes it to the surface, stays underground. Now look at your charts. That's right. So if magma cools, it becomes solid, much the same way that when water cools, it becomes ice.